What if a car engine could recycle its own exhaust and use it to power itself again? A closed-loop combustion system? Zero waste. Almost no emissions. It sounds like science fiction. But scientists and engineers around the world are experimenting with exactly that. Today, we're diving deep into the technology behind the carbon recycle engine. How does it work? Could it actually power a car? And is this the future of clean transportation or a beautiful idea that collapses under real-world physics? The viral clip shows an engine that captures carbon from its own exhaust pipe. Instead of letting it escape into the atmosphere, it compresses the carbon, filters it, and reuses it inside the engine as a secondary energy booster. The claim is bold: a car engine that feeds on its own emissions, creating an efficient, semi-perpetual loop. We're going to examine if that's actually possible. Before we judge the idea, let's understand the basics. A normal internal combustion engine works by burning fuel, usually gasoline or diesel. The fuel reacts with oxygen inside the cylinder, creating heat, pressure, exhaust gases, and wasted energy. Only 20 to 30% of the energy actually moves the car. The rest? Lost as heat and exhaust. The exhaust contains gases like carbon dioxide, CO, carbon monoxide, unburnt hydrocarbons, nitrogen oxides, water vapor. Traditional engines simply throw these gases out the tailpipe. Why waste the carbon when you can recycle it? The proposed system has three key parts. Carbon capture module connected to the exhaust pipe. It cools the exhaust and separates carbon particles. Compression chamber captured carbon is pressurized and liquefied, similar to how CO tanks are made. Reinjection system compressed carbon is fed back into the engine as a secondary fuel or combustion booster. Some systems propose mixing it with fuel. Others suggest using it to increase chamber pressure. Either way, the promise is the same. Exhaust, captured, compressed, reused, repeat. Now, let's break down the physics, because this is where the idea runs into trouble. Exhaust carbon is not fuel. Carbon dioxide, CO, is already fully oxidized. It has no energy left to burn again. You cannot use it as fuel unless you add new energy from somewhere else. It's like trying to reburn ash. Impossible. Capturing carbon takes a lot of energy. Carbon capture machines in factories require huge compressors, high-pressure pumps, cooling systems. Capturing CO from exhaust in a small car requires more energy than the engine produces. Recompressing CO doesn't give power. Compressing CO simply stores it. It does not magically become fuel again. Reinjection increases engine load. Feeding compressed gas back into the cylinder actually increases resistance, lowering efficiency. So scientifically, the process does not create energy. It uses more energy than it returns. This is why closed-loop engines are not used in any industry. Even though the closed-loop concept fails, there are versions of carbon recycling that do work. 1. Synthetic fuel production. CO can be captured and transformed into synthetic fuel, but only using solar energy, hydrogen electrolysis, industrial reactors. This happens outside the car, not inside the engine. 2. Turbocharging and pressure recycling. Cars already recycle exhaust pressure using turbochargers. They don't recycle carbon, but they recover energy. 3. Carbon nanofilters in cars. Future cars might include small carbon capture devices to reduce emissions. Not for energy, just for the environment. So pieces of the idea are useful. The loop is not. People love the dream of infinite energy, but thermodynamics doesn't work like that. Carbon dioxide is a waste product. Once it's burned, it's done. You can't burn it again. A real closed-loop engine would violate the laws of physics. You can recycle pressure, but not energy. The only true loop we can get is electric recharging with renewables. Let's be fair. Even if the closed-loop engine isn't possible, the concept still has some benefits. PRO1 encourage innovative thinking. Ideas like this push the boundaries of technology. PRO2 raises awareness about emissions. People start asking questions about pollution and clean tech. PRO3 could inspire real solutions. Even a flawed idea can spark a working invention later. Now the downsides. Con 1. Violates basic thermodynamics. You cannot get more energy out of exhaust than you put in. Con 2. Adds weight and reduces efficiency. Carbon capture equipment is heavy and power hungry. It would make the engine weaker, not stronger. People may believe in perpetual motion machines, which aren't possible.